conduction heat transfer through a cylindrical tube. So as we saw in our previous classes, for plate, we have the Cartesian coordinate for plate, which is x, y, and z. So for our cylindrical, we also have a cylindrical coordinate, but we have in the direction of r, theta, and delta z. Okay, so you will have r is the radius, theta is the degree, and z in the z direction. But similar to our plate, we'll be only looking at one direction. So if you look at here, we'll be ignoring the theta direction, and we'll also be ignoring the z direction. So we'll be only looking at in the radius direction, in the r direction. So based on that, you will get an equation something like this. So if you remember our general equation, Q is equal to negative Ka dt over dx, right? This is the equation for our plate. So if we are using a cylindrical, instead of having x here, we'll have r. So because our heat transfer, if you look at this figure, is going from in this direction. So that is the direction of Q. So we are, instead of taking the value of x, we'll put dt over di. And the A for plate, we define A as height times the width. But for cylindrical, this is how you define the value of A, 2 pi RL. Okay, so we are actually taking the area for this. This is the area we are taking. Okay, we are not taking the area of this area, because if you were taking this area, the formula for area for that area will be area is equal to pi r squared. But we are taking 2 pi r, so the circle times the length. So this is the length. So we are actually trying to see the area here, because this is the area perpendicular to the direction of heat transfer. So if you substitute the value of 2 pi r into the A here, so you'll get equation like this. And again, after we have these things, so we want to remove the dt over dr, we will do integration. After doing integration, you'll get, this is the equation that we will use for cylinder. Q is equal to K 2 pi L Ti minus To over ln Ro over Ri. So K, again the thermal conductivity, 2 pi is just a constant value, L is the length of the cylindrical tube, Ti minus To, so Ti here is the temperature inside, To is the temperature outside. So you'll have a temperature inside the cylindrical, and then you have temperature inside. So if I were to label, this is where your temperature inside will be, and this is where the temperature outside will be. And then divided by Ro over Ri. Ro is your radius outside, Ri is your radius inside. So this is if you have cylindrical. So remember, when you have a a tube, when we say a tube, the tube, okay, let's say this is your tube, you will always have an outer and inner diameter. Okay, so when you have outer and inner diameter, you will always have outer and inner radius. So tube will always have two circles inside it. Okay, one is inner circle, one is outer circle. So based on that, we know that we'll have inner diameter, inner radius, and outer diameter and outer radius. So that's how we define our Ro and Ri value. So this is for single wall cylinder. Single wall meaning that you have only two circles, so one layer only. So we can call this is one layer. Okay, if you have multi-layer, you will have resistance. Formula for resistance, R is equal to ln Ro over Ri over K 2 pi L. So similarly, remember, if we were talking about our flat plate, right? If you're talking about the flat plate, I put it here. The value of R, remember, R will have a value of R is equal to delta X over K. So for cylinder, the R value is equal to ln R0 over Ri over 2 pi L. So this is the difference. Everything else will be the same. So let's say if I were to write the equation for multi-layer wall. So I know that my Q overall, Q over A overall is equal to delta T overall over R overall. And here I put that Q is equal to delta T overall over R overall. So it's similar. The only difference is that here you have the A value, here you don't have the A value. Now when we are solving the equations, sometimes depending on your questions, you will have an equation for your cylindrical, something like this. Okay, let's write it here. So instead of having Q is equal to delta T overall over R overall, you can have Q over L is equal to delta T overall over R overall. So you must be able to differentiate and understand the question and know when to use this equation. Okay, it's either this equation or this equation. So for your cylindrical soup, so you use this equation when the value of L is not known. When you don't know the value of L, you will use this equation. When you don't know the value of L, the formula for R here, instead of having R is equal to ln Ro over Ri times divided by 2 pi L, you remove the L here because you don't know the L value, so you put it the L value here. Okay, so depending on the question, if the value of L is given, then you just put the L value here. If the value is not given, then you put the L value here. So when you are using this equation, the unit you must remember, since it's Q over L, so unit will be watt per meter. For this one, the heat flux is watt per meter squared. For this one, because Q has a unit of watt, L has a unit of length, which is meter, so your unit must be Q over watt over meter. So for this equation, Q, since it's just Q, then it'll have a unit of watt. So that is why it is important for you to actually understand and know all the units, because when you do unit cancellation for this part, okay, when you are doing unit cancellation, delta T over R overall, based on what is the value of Q, if it's Q, then your unit must cancel out all the units, and the only remaining unit will be W. But if it's Q over L, then you must cancel out all the units, and the remaining unit must be watt per meter. Then you know that your answer is correct. Okay, so this is an example. So first of all, let us see what is the question. So example number 5, calculate the heat transfer to a copper tube 5 mm in length. Okay, so first of all, we know this is the length 5 mm with an inner diameter of 80 mm and an outer diameter of 100 mm. Okay, the inside temperature is 200, so we know that this is Ti, and the outside temperature is 70, so we know our To. So if we were to put everything, so I would prefer if you draw before you solve, meaning that just draw whatever information you have. So let's say we have our inner diameter, our outer diameter, and then this is a tube, so we'll have a length of the tube. So just put whatever information that you can put. you know that your value of di, diameter inside is 80 mm. Diameter outside, do is equal to 100 mm. The value of L, your length, is given as 5 mm. And then your temperature inside, your Ti, is equal to 200 Kelvin. Your temperature outside, To, is equal to 70 Kelvin. And the K value, K for copper, is given as 385 watt per meter Kelvin. So these are the information is given. But if you look at the equation, we will need to find the value of Rho and Ri. Because our equation, we need to find the value of Rho and Ri. So Ri is just di minus di divided by 2. So it is 40 mm. And the value of Rho is equal to 50 mm. Okay. So these are all the informations that you have. So now, the next thing you have to do is you have to decide whether this is a single cylindrical tube or a multi-layer cylindrical tube. So again, you look at, if you draw it, you will know, okay, so this only have one layer. This is the only layer we have. So automatically you say that this is a single layer cylindrical tube. So the equation you will use is this first equation for single layer cylinder wall. Right? So if you look at this equation, you want to find the value of Q. The K value is known, 2 pi L is known, Ti and To is known, and your Ro and Ri is known. So when you know all this value, when you substitute, you get a value of Q in terms of watt. Okay, so let us just try to solve this question. Let's add a new slide here. Okay, so I will show you for this example how do we solve this. So again, always try to draw everything that you have. So you can see whatever you have and whatever you don't have. So again, my Ti is equal to 200 Kelvin. My To is equal to 70 Kelvin. My Ro is equal to 50 mm. My Ri is equal to 40 mm. My K value is equal to 385 watt per meter Kelvin. And then my L value, the length of the tube, is 5 meter. So if I were to write the equation, Q is equal to, one second, what is the equation just now? Q is equal to K times 2 pi L Ti minus To over ln Ro over Ri. So you have all the informations. So when you substitute the equation, so first thing here, I would like to highlight for you is that, remember, in the previous questions, I always stress that it is important for you to change everything from, if it's not SI units, change it into SI units. But this one, it is up to you whether you want to change it or not. Why? Because let us just say, if I just take this, okay, I just put here ln Ro over Ri. So why I don't think that it is not very important for you to change the unit, because when you put in here ln 50 over 40, so it's going to be mm over mm. So the unit will cancel out each other. So it's going to be the same. The answer will be the same if you put ln 0.05 over 0.04. So this is in meter over meter. So if you put in your calculator, you should get the same value. So that is why if you think that you will be able to solve this without changing the units, go ahead. But if you think that it's easy for you, if you change all the units, so it is better and it is safer for you to change the unit, everything into SI units. But if you can see here, you will get the same answer, whether it is in mm or whether you change it into meter, depending on you. So if you are not confident enough, so better you change everything into meter. So once you have put in all the values, you know the value of K, you know the value of L, you know the value of Ti minus To, and then you know the value of Ro and Ri. So let's say if we do this one, Q is equal to, K is 385 watt per meter Kelvin times your value of 2 pi, which is just a constant, times the value of L, which is 5 meter, times the value of your Ti minus To. So 200 minus 70 is going to be 130 K, divided with the value of ln 50 over 40. So mm over mm. So if you do unit cancellation, meter here will cancel out with this meter, Kelvin here will cancel out with this Kelvin, and then 2 pi has no unit, so this mm will cancel out with this mm. So you will get an answer of the answer is, if you put in your calculator, you'll get 704,638 watt. So this is the final answer. Okay, so this is how you solve these questions. So it is best, draw first, label, see all information you have, and then try to solve it. Because if you don't label it, if you don't draw it, sometimes you will use the wrong information. And make sure you understand what does diameter means, what does length mean, and which is which. Okay, so that is example number 5. So if you look at example number 6, it is saying that along 1 meter. So again, we know the length. So this is your L. 1 meter long pipe with an inner diameter of 120. So this is your Di value. Has a wall thickness of 10 mm thick. The pipe is covered with an insulation of 20 mm thick. So we have an insulation of 20 mm thick, and the thermal conductivity of steel is 60 and for insulation is 0.08. The pipe carries steams at 150 degrees Celsius and the outer surface temperature of the insulation is 0 degrees Celsius. Calculate the heat loss and the temperature at the pipe outer layer. So I have given to you the solution. This is the correct answer. Okay, so you must be able to use all the informations and try to find the correct answer. So let's say, so for this one, I'll just show you what is the difference between the multi-layer wall and the single layer tube. So first of all, if you look at the questions, so again, draw first. So you have a steel tube. So if you say tube, or so you will have this first. Okay, and it's saying that your inner diameter, so your Di, the value is 120 mm. Okay, and it says that it has a thickness of 10 mm. So you have a thickness of 10 mm. This is your thickness. So, but it did not tell you the outer diameter, right? It just told, the question says that the tube or the pipe has a inner diameter of 120 with a thickness of 10 mm. So you must understand how to get your outer diameter if you are given the value of thickness. So DO, which is your outer diameter, is going to be equal to DI plus 2, let's say the thickness is going to be X. Okay, so this is how you get the value of your DO. Why we are saying 2 times the thickness? Because you can see here, this is the first thickness and this is the second thickness. So in order for you to get this whole diameter, you have to add the inner diameter, which is from this point to this point, plus this value and this value, right? This value, okay, which is your thickness number 1 and thickness number 2. So that's why you plus 2x. Okay, so but in our case, we are more concerned on the radius, right? So we are not looking at this diameter. So let's draw again. So this is just to let you know how to get the diameter. So let's draw again. So this is your inner diameter. This is your thickness. Okay, so di, again we write di is equal to 120 mm. Your thickness, so you can say DO, you can get your DO value is 140 mm, because 120 times plus 2 times 10, so you get 140. And it says that you have an insulation layer, so you have another layer here, insulation layer of 20 mm thick. So this thickness is 20 mm. Okay, so based on this figure, you see that you actually have 2 layers of tube. This is the first layer and this is the second layer. So if you have 2 layers of tube, then you know that you have to use the equation of R, right? So R is equal to ln R0 over Ri over 2 pi K L. Now remember, since you know the value of L here, so in the R equation you can put the L here. If you don't know, then just put ln Ro over Ri is equal to 2 pi K. So now you know that you're going to use this equation, and the question is asking you to find the value of Q, right? You have to find the value of Q. So you know that if you are using the value of R, then automatically you know that for Q is going to equal to delta T overall over R overall. So your R overall is going to be R for, let's say this, we just put this as layer A and this as layer B. So it's going to be RA plus RB. So you have to find the value of RA and you have to find the value of RB. Now, in order for you, let's say, I'll just show you how to find the value of RA. So R for RA. So for RA, this is layer number 1. So you have to find what is the RO. Okay. You have to find the value of your Ri and Ro. Okay, so you have to find these 2 values. So based on the first layer, you know that your Ro and Ri is going to be, so this is, let's say this is center point, this is your Ri for layer A, this is your Ro. So based on the information, I can put here that my Ro and Ri is equal to 60 mm and Ro is equal to 70 mm. So once I know this, I can just put in this equation and I can get the value for Ra. So you can do the same thing for your Rb. So for Rb, you also need to decide what is your Ri and what is your Ro. So Ri for layer B. So this is layer B now. So layer B, this is your layer B. So from here to here, this is your Ro. No, sorry, Ri. So your Ri is going to be 70 mm. And then your Ro is going to be from the center point to the insulation layer. And you know that the thickness of insulation is 20 mm. So 70 plus 20, you get the value of Ro is equal to 90 mm. Okay, once you know all this value, you can find the value of Rb. So once you know the value of Rb, you can find, so let's say I tell you Ra will be equal to 4.08 0.89 10 to the power of -4, and Rb is equal to 0.5. Let's say. So you can find the value of your Ro is equal to this plus this one, Ra plus Rb. So you'll get a value of 0.5004. So once you know the value of Ro, you can find the value of Q, because you can easily find the value of your delta TO. Delta TO is going to be equal to Ti minus T outside. And you know, based on the question, it has given you Ti is 150, T outside is 0. So the delta TO is going to be 150 degrees Celsius. So once you know this value, you can just put in the value here. So Q is equal to 150 degrees Celsius divided by 0.5004. The unit here is Kelvin over watt. So once you do this, you'll get the value of Q. Okay, so this is how you differentiate between your single layer tube and multi-layer tube. So before we continue, do you have any questions to ask me?
For unit of R is Kelvin. Do we need to change to Celsius?
Okay. So let me just write everything here. So first of all, unit of Kelvin, change to Celsius. Okay. So if you're asking for the value of Q, right? This one, the one we put here, this one, right? So now, as I mentioned in our previous class, let's say I do something like this. Okay, let's say I have 150 degrees Celsius, but my value of Q, R, let's say, is 0.5 Kelvin per watt. So how do I cancel out this Kelvin and this degree Celsius, right? So this rule only applies when you are doing unit conversion. Okay, so the rule is that 1 degree Celsius is going to be equal to 1 degree Kelvin. Okay, so because of that, I can just cancel off degree Celsius and Kelvin. So if you think that you are not sure, so let's say if you're not sure whether you can do this or not. So first of all, you want to know what is your value of. So let's say now we have our temperature just now was Ti is equal to 150 degrees Celsius. To is equal to 0 degrees Celsius. Now if you convert this 150 into Kelvin, you'll get around 223. 150 plus 273, you'll get 423 Kelvin. Correct me if I'm wrong here. And then for degree Celsius, you get a value of 273 Kelvin. Okay, so this is in degree Celsius, this is in Kelvin. Now if I were to divide 150 divided by 0, I'll get 150 degree Celsius. The same thing I do. 423 minus 273, I'll get 150 Kelvin. So this is what I mean. This rule is only applicable when you are finding temperature difference, because our value of 150 degrees Celsius and 150 Kelvin is our value of our delta T. Our delta T is equal to 150 degrees Celsius, or our delta T is equal to 150 Kelvin. If you are using this, then you can automatically cancel degrees Celsius and Kelvin. Okay, so if let's say you are still not very sure whether you can do that or not, so based on this rule, so let's say we have just now 150 degrees Celsius and 150 degrees Celsius, you divide with, let's say, 0.5 Kelvin over watt. You can just use something like this. 1 Kelvin is equal to 1 degree Celsius. So if you cancel out degree Celsius with degree Celsius, Kelvin with Kelvin, so the only remaining unit is your watt unit. Okay, so this rule is only applicable when you are using it for temperature difference. The value of delta T here is the temperature difference between temperature inside and temperature outside. This is also temperature inside, this is also temperature outside. You cannot use this one when you are changing the unit from degree Celsius to Kelvin, because if you are changing degree Celsius to Kelvin, degree Celsius to Fahrenheit, degree Celsius to Rankine, you have its own specific equation. But if you are just changing the delta, the temperature difference between Kelvin, degree Celsius and Kelvin, you can just use 1 degree Celsius is equal to 1 Kelvin. Okay, clear? Any other questions?
Yeah, doctor, thank you.
Okay, anybody have any other question? No questions? Okay, so no question, so we can move on. So that is how you are supposed to solve this example number 6. So don't worry, the detailed steps on how to solve example number 6 I will put in the pre-recorded video, so you can check this out when I upload it into the next lesson. Okay, but this one I just want to show you that you have to be able to differentiate between the multi-layer tube and the single layer tube. And please try to go back. If let's say you cannot imagine how a multi-layer tube will look like, go back, look at your maybe your pipe in your bathroom or pipe in your house or anywhere. Every pipe will have a inner and outer diameter. Okay, when we're talking about pipe and tube, it will have inner and outer diameter. There will be a thickness. Sometimes this thickness is not that big, it's not that significant, but it will have a thickness. If a metal tube or metal pipe have a thickness, it will have an inner and outer diameter. And when you put a layer on it, so you will have another thickness. Then if you put a layer on it again, you will have another layer of thickness. So if let's say I give you a question something like this, so you must be able to identify that this is layer number 1, or we get it layer number A, this is layer B, and this is layer C. So you have to find the value for RA, RB, and RC, because we say that for this case, your R overall will be equal to RA plus RB plus RC. So for each RA, RB, and RC, you have to find what is the R inside and R outside. So for RA, what is the R inside, what outside? RB, what is the R inside and what is the R outside? RC, what is the R inside and what is the R outside? If you can do that, then it will be easy for you to solve for Q or any other things. Okay, that is the first part of this question. The second part of the question is asking us to find the temperature on the outside surface of the steel pipe. Okay, the first part was to find the value of Q. The second part is to find the temperature outside. So if I have to redraw again this is your inside diameter, this is your outside diameter, and this is the layer of insulation. So this is your inner wall of the steel pipe, this is the outer wall of the steel pipe, and this is the outer layer of the insulation. So based on this question just now, it is asking us to find the value of outer wall temperature, so which is going to be this temperature. We know the temperature inside here is 150. Temperature here, this is 0 degrees Celsius. Temperature here is 150 degrees Celsius. We don't know what is this temperature. So if you were to label this one we can say this is T1. So T1 or T inside is equal to 150. T outside is equal to 0, but we don't know. Let's say we label this as T2. So we don't know what is the temperature of T2. So we have to find the temperature of T2. T2 is unknown. So how do you find the temperature of T2? The same applies for this one as the rule for multi-layer wall. We say that the Q overall, Q is equal to QA is equal to QB is equal to QC. So in our case, we can label this as QA, this is B. So we can only say that Q is equal to QA. So we know that for Q is equal to delta T overall over R overall. QA, if it's A, then we're going to put delta TA over RA. So once we know the delta T overall, we have calculated the R overall, and we also calculated the RA. So delta TA is just T inside minus T2, which is the temperature that we want to find. So once you get the value of delta TA, you already know the value of T inside, which is 150 degrees Celsius. So T2 is going to be T inside minus delta TA. So that is how you find the value of your T surface of the pipe. So that is all for this example. So you can expect your test questions and your final exam question to be something similar to this kind of questions. Okay, everybody clear? Do you have any questions to ask? Okay, if no questions, then we can continue. So for the last part, we have looked at for wall, for tube, for cylindrical tube. Now we're going to be looking at spherical, our sphere. So again, the same thing. It's going to have 3 coordinates, our Cartesian coordinate. So we're going to have in terms of our dr, okay, dr, d theta, and r sin theta. So again, we are going to be looking at only one direction, which is the value of dr. So similar to our cylindrical tube, the area for the sphere is like this, 4 pi r squared. You substitute the value into the general equation. Again, the general equation, I just write here, Q is equal to negative Ka dt over dr, because we are talking about in terms of radius. So you substitute the A here with the 4 pi r squared, and then you do integration. You'll get equation like this for a single layer sphere. Q is equal to K 4 pi Ti minus To over R to the power of -1 minus Ro to the power of -1. This is for a single layer. For a multi-layer sphere, meaning that there is a layer covering your sphere, you have to find the value of R. And then it's going to be the same. Your Q value is going to be equal to delta T overall over R overall. And this is the formula to find the value of R. So again, this is an example. So please go back and try the example. I have given you the answer for this example. This is the answer. So first of all, again, try to draw everything and then label everything, and then only try to solve. So I think that is all for conduction heat transfer steady state. If you have any questions, please ask me.